Hello everyone. In this session we learn about fuzzy logic control approaches. In previous session I told you about what is a fuzzy logic, what is the difference between a crisp logic and fuzzy logic, how crisp set is different from fuzzy sets, importance of member functions, and how we design a control system that is operated by fuzzy logic with different examples. And in this session we discuss about fuzzy logic control approaches. Means basically we use logic to infer something from the system. So how we infer, how we apply the logic, how we get the consequences, that is an important task. In a normal logic we have different approaches like a propositional, predicate, and different representation of the logic. But in fuzzy, how we infer a thing, means for this we have some standard approaches of inferences. We can also say types of controllers we use in our fuzzy systems. There are two important ones, Mamdani and TSK approaches. These approaches help us or guide us how to define a control system using a logic inference. So first let us go through first approach of Mamdani fuzzy models. These fuzzy models first in 1975 Abraham Mamdani he designed this kind of a inference, fuzzy inference. So basically this was designed to control a steam engine or boiler combustion. Means people who work in that environment, they know the rules of that environment. So they know how to apply, how to infer a new thing by repeated processing of these rules. Now the same thing here he inspired from that, and he prepared this procedure how a fuzzy control system works with the help of a rules evaluation. So he performed here in this Mamdani style fuzzy inference process. Fuzzy Mamdani style fuzzy inference process means the process of making conclusions or making decisions. So in a environment where it is uncertain, means we can't expect what is the outcome of that environment, or we can't predict that environment, imprecise environment where decisions always difficult. It means crisp decisions are always difficult. In such environment, how a fuzzy control should take a decision with the help of a rule evaluation. So first step in this Mamdani fuzzy inference is fuzzification of the input variables. Second step, rule evaluation. Third step, aggregation of the rule outputs, and finally fourth step, defuzzification. So what is a fuzzy inference engine in this control system? Uses basically if then type fuzzy rules, means that converts fuzzy input to the fuzzy input. Suppose a crisp input, like a control system has to take a decision based on one parameter, a crisp parameter x bar. Now here we define some rules. If x bar is a1, then it implies y is b1. That is a consequent of this one. If it is a2, then y is b2. a3 is y is b3. Means output of my inference is output of this consequence. They are all put together, aggregated, and one final fuzzy information is given, and that is again defuzzified, and a crisp output is generated. Let us see a small example. Suppose in my control system I defined that if x is a3 or y is b1, then z is c1. This is one rule. Like also I can say if project funding is adequate or project staffing is small, then risk is low. So that is like this. If x is a2, like b2 and c2, then z is c2. Like this, if or then, or and with help of or and conjunctions, I prepared these fuzzy rules. So after preparing these fuzzy rules,
अभी कैंसिल करो उसको
So what we do, we apply one membership function to these fuzzy rules. See, x1 for each rule I give a membership function. A membership function basically assigns values to the fuzzy set values. I think we already discussed about this topic, how a membership is assigned. So based on strength of those memberships, okay, the rules that we defined we can show in as a pictures. So here the rule, if x is a3, here I defined the rules as if x is a3 or y is b1, then z is c1. Now this rule, what I do for this rule, for these variables a3, b1 and c1, I assign a membership function. Membership function gives that how much this variable has a strength in this particular rule, means how much it can impact that rule. Like this, some membership values are given to each one. So if x is a3 0 or y is b0, means here or means in terms of fuzzy logic, it is a union of two rules. Nothing but here I am performing a union of membership values. In a normal crisp sets, union is a collection of this, combining these two sets. But here suppose mu of A union mu of B, means a membership applied on A, union membership applied on union. R is always shown with the union. That is nothing but maximum of memberships of this what is the value of mu of A comma mu of B. So in that case here z will become z is c of 0 1, means R indirectly is nothing but a union of membership values assigned to Z. Similarly, AND means conjunction of membership, like mu of A and mu of B. In normal crisp sets, it's the intersection of two sets, but here in this fuzzy sets, this is nothing but a minimum of assigned this one. Now here it takes as a 0.2 value. Like this, for every rule, membership assigns rather than directly giving, a rule is evaluated first with the help of a membership values, if that satisfy based on their and or and conjunction, and finally a new decision is taken, like if then if A3 or B1 then C1. This kind of to get this inference, it should satisfy the associated membership values of that function. So after this, whatever the output we got, again that is defuzzified, means finally my fuzzy control system should crisp set is sent, each rule is evaluated by assigning a membership function values to each of these variable that is participating in that rule. Finally their fuzzy outputs strength of these they are combined together as aggregator and finally sent to defuzzifier. Defuzzifier gives the correct action should be performed. Here x is the input, it can be A1, A2, A3, then what should it perform, that is decided by defuzzifier. So these are the 4 steps involved in Mamdani approach of fuzzy reference: fuzzification of the input variables, rule evaluation, aggregation of the rule outputs, and finally defuzzification. Another approach of this fuzzy logic inference is Sugeno fuzzy models. We also call it a TSK fuzzy model. Takagi, Sugeno and Kang 1985 they approached. So they also followed the Mamdani approach, but instead of this this consequent, what they do, they gave a function. See, if x is a and y is b, then z is a function of x comma y. Means rather than directly z giving a member value to z, we are calculating this relation between this x and y, and then we are taking the decisions. Like these are fuzzy inverse discourse is a mathematical function. So these fuzzy rules, same rules, a small change in the right side of that rule. Instead of a fuzzy set, here he used a mathematical function of input variable. So the most common zero order solution of fuzzy model, if x is a and y is b, then z is k, where k is constant. So generally here fuzzy rules of TSK model is like here a and b are fuzzy sets, then the function that output function is giving as a crisp value. So crisp function means directly, rather than going for concluding something, before making a conclusion, we are also trying to study the relation between the input variables that participated in this rule. That is the basic logic. So the rules in this TSK is like, if x is small and y is small, then I define one function z equal to minus x plus y plus 1. So my crisp set should satisfy this functions, like if x is small and y is large, then z is minus y plus 3. If x is large and y is small, then z minus, like this. These rules are evaluated during the fuzzification process, which rule, whatever the rule has highest membership values, those are all aggregated together, and final a crisp decision is taken. Like this, a fuzzy control systems, they infer the logic. Thank you.